Hi, this is Mr. Brown. This podcast is for CNT140. We're looking at Chapter 9 on user cords and connectors. All right, we're going to look at the connector ends, pinouts, types of patch cords, and we'll just highlight making user cords. I have a separate podcast for actually making our patch cords. The book does a distinction between cable and cord. Cords are what we would call patch cables, if you will, and cable is basically the horizontal cabling. So the book kind of divides it up that way. Okay, I normally say patch cable or horizontal cabling. That's usually what I say. So I kind of go with patch cable or horizontal cabling as my distinction. This chapter we're focusing in on the patch cables at each end. So just a super quick review. We started off with, back in Chapter 5, talking about cabling, so we pulled the horizontal cabling in the lab. As we talked in Chapter 6, we talked work area outlets, so we turned right around and terminated the outlet jack here. Chapter 7, 8, we talked about terminations in the closet, and then talked about patch panels, so we terminated our patch panel here in the lab. Now at Chapter 9, we're looking at patch cables that we would use here in the closet to go from patch panel to switch, as well as patch cable out here at the work area to go from the work area outlet, out to your user computer. So we're looking at those pieces of our system, the patch cables on each end of our horizontal cabling, if you will. That's the part we're looking at now. First thing the chapter mentions is our modular cable and connectors. They come in a number of configurations. We're focusing mainly on a twisted pair, so we're going to be looking at what we would call RJ, but before we dig into that, they actually do come in a couple different configurations. 4-pin, which is typically called RJ11, 6-pin, which is typically called RJ12, and our 8-pin that we would use for data connections, what we would call RJ45. Really referred to by your USOC, RJ number, even though it's not really used for that, but that's technically what's really USOC, but most people just slang call it RJ45. So we'll just kind of go by the slang name that most people use. If I look at my 4-pin modular connector, a lot of people call it RJ11. That's your 4-pin. This would be a typical phone line, analog phone that I would use. 6-pin here, or RJ12, you encounter that sometimes with phone wiring, sometimes with multiple phone lines in a connection or in a building, you run into an RJ12. And then last, the one we're most concerned with, our 8-pin modular connector, or RJ45. That's the one we most are concerned with. According to the standard 568C1, all of our terminations should be in a modular connector, if you will. Each 4-pair cable and equipment outlet shall be terminated in 8-position modular jack. Well, if I'm terminating all my horizontal cabling in modular jacks, then therefore I need to use a modular end connector, RJ45, to plug into that jack. So the standard doesn't come right out and say RJ45, but since we have to use modular 8-pin connectors for our outlet jacks, we don't really have any choice but to use the modular 8-pin connector to plug into that outlet jack. So they do specify it in that manner. These are really intended for terminating cable with stranded conductors, because of patch cables are stranded conductor for flexibility. These are really designed for terminating stranded conductors. The TIA specifies performance criteria for these, next in attenuation, and actually if you look in the 568C2 standard, there's a number of charts in there that show you attenuation near and crosstalk levels for these cables and these connectors. I don't need you to know that, but I just wanted you to recognize that that actually is in there in the standard saying how these connectors should be performing. Again, here's another reminder of your RJ modular 8-pin connector, RJ45, versus our 4-pin modular connector, what we would call the RJ11 that we would use for phone. Make sure you can see the difference there. Make sure you recognize the difference. Again, here's looking at from the front, RJ45 versus RJ11, modular 8-pin versus modular 4-pin, if you will. And then there's your RJ jack, if you will, RJ11 jack and RJ45 jack, if you will, just comparing the difference. The author did a quick tangent on the one page. There was a gray insert there that he talked about RJ45, what's in a name. And the author does have a point. The modular 8-pin connector is usually or improperly referred to as an RJ45. RJ45 describes a particular interface, etc., etc., etc. I at least point out the author's note because it is important that you at least recognize this. I'm not going to get hung up if you call it an RJ45, but what you do run into is you're going to see these connectors listed as RJ45s. You're going to see them listed as modular connectors. You'll see them listed as modular 8-pin connectors. So as you go to order these or go to talk to people or go to confer with other technicians, usually recognize these names because they kind of, the same connector goes by these multiple different names. So don't let that throw you. I remember one of the first times I ordered these connections to do patch cables many, many years ago. I tried searching, I think it was RG45, and I couldn't find it, but I found them under modular 8-pin connectors. So just recognize these couple different names for the same thing. Again, I'm not going to get hung up on what you call it. Just recognize those names. So modular cable end connectors are modular end connectors that we would be dealing with. They do come in two variations. A modular end connector for stranded wire, and one that is for solid wire. This one is discouraged. We're not really using this one, but I want to point it out so you at least recognize it. If you remember, let me zoom back here real quick. Oop, hold on. There we go. If I zoom back to the beginning here, when we talked about our horizontal cabling structure here, our structured cabling, the horizontal cabling is solid wire. The solid wire is designed to get terminated into a modular 8-pin or modular outlet jack here, work area outlet jack. That's what it's designed to be terminated into, and designed to be terminated into the patch panel. The patch cables are supposed to be stranded conductor and are supposed to be terminated into these modular 8-pin connectors. So keep that in mind. That's how things are designed. The horizontal cabling solid conductor wire is designed to be terminated in the patch panel into the outlet jack. The patch cable stranded conductor is designed to be terminated into these modular 8-pin connectors that we're talking about. So let's quick look at the difference between them. And this is where the book shows it a little bit, but it's kind of hard to see. If I see a modular 8-pin connector with 3 prongs in there, that is typically designed for solid conductor UTP. Again, we're not going to use those in our lab, and we're not going to terminate patch cables with solid conductor, but they do exist. They are out there. Meanwhile, if you see a modular 8-pin connector with 2 prongs in, this is really designed for stranded conductor. I have a couple more pictures to show you. Here's the RJ modular 8-pin connector, RJ45. Here is a pin that would be in here. That's one of the brass pins designed for stranded conductor. It's designed to pierce through the insulation, make contact with the stranded wire inside. Meanwhile, one that has 3 prongs like this is designed to cut through the insulation, and those 3 prongs are designed to go around the solid copper conductor in the middle. 2 on this side, 1 on the other side. Almost like fingers coming down across something. That would be the style designed for solid conductor. So if I back up real quick, if I see a RJ45 with 3 pins in, that's really designed for solid. Meanwhile, an RJ45 with 2 pins in is designed for stranded. So going back to here, this is a solid one. Down here is a stranded one. So just be able to recognize that if you're dealing with connectors and you're terminating, things are failing, take a good look at these. You might be using the wrong connector. Somebody might have bought the wrong connectors for toolkits and so forth. We're going to be dealing with stranded conductor for patch cables, and we're going to be dealing with stranded connectors. That's what we're going to deal with when we terminate everything. We're trying to do everything right as much as we can for you guys. They do make modular end connectors for shielded connections. Well, as we start moving into category 6, category 7, there is shielding on there. So the connectors themselves should be shielded. And here it looks like an RJ45 has just been wrapped in metal. And that's essentially what it is. And when I terminate the RJ45, the shielding that I kind of roll back a little bit, it'll make contact with this shielded conductor. So the idea is the shielded cable that's picking up the noise and interference will terminate to this, and this will make contact with the the NIC port or the switch port that, if you carefully look at it, has a metal ring around it. All my noise that my cable's picking up makes contact to here. This makes contact to the metal ring going into my NIC or into my switch port, and all that noise is being sent to ground. So they do make these shielded conductors for my screen twisted pair cable that we're going to start seeing more of when we deal with Category 6 and Category 7. So these are out here as well, and that'll be something kind of on the horizon for us. Here's another look at the same thing. It's just kind of like, it almost looks like it's wrapped in foil, if you will, and that's kind of what it is. Here would be an outlet jack that is actually shielded. As you see, it's all metal. So as I plug in, again, my cable, the shielding on my cable is picking up the noise, makes contact with the connector. As I plug into here, it's making contact here, and all that is getting attached to ground, and all the noise is being sent away. My wiring patterns for these modular cabling connectors are specified in our 568C0 standard. Actually, let me pop that up. I think I have that back here. Let me do this right here. Yeah, there we are. Here is my 568C standard. There's C0. As I start working my way down through here, just a couple pages down, here is my modular 8-pin jack pinout, if you will. There's my color codes. So I'm going to pop back over here. Virtually all of our LAN equipment can be supported by either one of these, including the way these are pinned out. The way these are pinned out would actually support phone lines, which we've mentioned before, and I'll mention that again as we look at the pinout closer. Well, one of the first things we need to start identifying or recognizing is when I look at the RJ45 connector here, when I look at it straight on with a little clippy tab up top, pin 1 is on my left. Gotta go 1 to 8, left to right. My outlet jack, that we already terminated in the lab, when we go to plug our patch cable in, the outlet jack is going to appear backwards. And that's because as we start pairing these up next to each other, here's another view of the RJ45, pin 1 to 8. There's the outlet jack 8 to 1. As I start pairing these up, now I know this picture's rolled over, but here's pin 1 over here. As that slides in the outlet jack, pin 1 over here, as I look at these pictures back here, it seems backwards when I'm looking at them side by side, but when I start plugging them together, it does line up. Pin 1 here lines up to pin 1 here, because there's the clicky tab on the bottom now. It does work. It just seems weird. So if I look at my 568C0 part of my standard, in here the 568 color code, 568A color code is listed as thus. Here's my pair 1 right here in the middle. Pair 2 is right around it. Now let me point that out first. This is from the days of phone, because again, when we first started talking structured cabling was designed to handle phone and data. So this outlet, when I look at it, these two wires here in the middle would be phone line number 1 when I'm dealing with phone. And right around it is phone line number 2. So you have tip and ring here in the middle, and then I have tip and ring on the outside, if you will. So this is in this arrangement that way I can actually plug a phone cable right here in the middle. I could plug an RJ11 in the middle of this outlet jack and have it work as a phone line. That's why this is a cabling standard that will support data and phone. So it looks weird that they're in the middle like that, but it's kind of laid out that way on purpose because of phone. Then I see my pair 3 on the left and my pair 4 on the right. So when I start looking at my color code left to right, that's when I get the white, green, green, white, orange, blue, white, blue, orange. They're split here in the middle, and then white, brown, brown. And my B color code, my oranges are over here on the left, my greens are split around the middle, blues in the middle, and browns are on the right. Well, that might be a little tough to see, so I found some other pictures that are color-coded for you that might be a little easier to visualize. There's your white, green, green, white, orange, blue, white, blue, orange, white, brown, brown for your A color code. And then over here is your white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. There's your B color code. Whatever one of these seem to work for you, use them to follow them. But you will need to pay attention and learn these color codes, especially as you're making your patch cables, but then as time goes, you'll need to recognize these for troubleshooting. So you will need to know these. I unfortunately don't have a tricky way to help you remember them. But there is your A and B color codes for your outlet jacks and your modular end connectors. Here's another picture too, showing the wire pairs, color code left to right. So, whatever one of these that works for you to help you learn this, make sure you do that. All right, I'm going to stop there. I'll come back in the next podcast.